Hello, everyone, and good morning. Welcome to the final day of the 2021 PE Bootcamp. Welcome to this session, Code of Ethics, Canon 2, What is Competence, presented by Rebecca Bowman of NSPE. Thank you guys for joining us, and you can get started whenever you want, Rebecca.
All right, thank you very much. I come to you this morning as your Senior Director for Ethics and Professional Practice at the National Society of Professional Engineers. That means that when you call the hotline, you will get me. I do tend to keep odd hours, so please don't call me at odd hours, but you're welcome to send me an email, and I will get to it as quickly as I am able. Now, one might ask, why should you listen to me if I'm talking about ethics? Well, a couple of things come into play. First of all, I am a licensed civil structural engineer. I am also a licensed attorney. I have certifications in arbitration, mediation, and Christian conciliation. And just so nothing gets stale, I started back to school this fall at Penn State University, pursuing at least a certificate in sustainability policy. There is a master's. I don't know whether I'll do the whole master's or not, but I'm doing a certificate in sustainability policy. So I'm trying to stay on top of things. I come to you with many years of heavy construction experience, as well as residential, commercial, and industrial. So I've been around the construction block. I've worked in HVAC, so I've branched into mechanical up to a point. I stayed as far away from electrical as I could, but that's where I'm coming from. And I was talking with my husband this morning about the fact that I have always loved materials. So as we go through our session together today, you will notice that I pay a fair amount of attention to materials. When I was a little girl, my first construction toy was a set of antique blocks that were my mother's. And then I graduated to Lincoln Logs and then Tinker Toys. And when I was young, erector sets came out and I was seriously excited. Now, Legos came out later. I didn't find Legos nearly as satisfying because they're not so flexible. But in any case, from toddlerhood, I've been interested and excited about materials. So that is the special lens, if you will, that I bring to our conversation this morning. So the NSP Code of Ethics serves as a set of model rules and guidelines for the ethical behavior of licensed professional engineers. One of the questions that comes up very often is, well, what about companies? Well, the Code of Ethics doesn't apply to companies. The Code of Ethics governs the behavior of individual licensed professional engineers. So technically, the firm for which you work is not bound by the Code of Ethics, but all of the individual professional engineers are. So that's how it works relative to a firm. It governs the behavior of a professional engineer, whether the engineer is on the job or the engineer is enjoying private life. The same obligations accrue no matter what the circumstances. One of the issues that has come up in recent years is engineers responding to disasters. Some states have passed what are called Good Samaritan laws, and some states have not. So if you respond to an emergency in a state that has a Good Samaritan law, as long as you have acted in good faith, you are protected from liability. If you respond to a disaster in a state that does not have a Good Samaritan law, you may be exposed to some liability for the quality of your work. So just be aware of that. We are looking today specifically at Canon 2, and that is focused on competence. So we're going to look at what is competence, how do you know it, how do you know when you don't have it, and how do you get it if you're missing it. So let's take off. All right, Canon 2. Engineers shall perform services only in their areas of competence. Now, the Code of Ethics is set up with 3 tiers of advice. The canons themselves are the first section. Then there are professional obligations, and then there are rules for practice. We're going to walk through all of them and how they affect competence. So that's Canon 2. Engineers shall perform services only in areas of their competence. Under the rules of practice, we have 2A. Engineers shall undertake assignments only when qualified by education or experience in the specific technical fields involved. Now, this is a fairly broad fence, a very large fence that you're in, especially if you're in a state it is not practice-specific licensing or discipline-specific licensing. So this is a self-evaluation. In the specific technical field where you're considering doing work, are you qualified by education or experience to competently perform the service? Now, I know that sounds a little bit circular, but if we define competence as qualified by education and experience to determine competence, but those are the things that we look at, education and experience. So practice 2B, engineers shall not affix their signatures to any plans or documents dealing with subject matter in which they lack competence. Now, this comes up most often when you have an engineer of record. And the engineer of record over the whole project may be a civil structural, but there are plumbing drawings and there are electrical drawings. And the engineer of record may not be competent to sign off on those drawings. So it becomes important that you recognize your limitations and make sure that you have appropriate support in the form of competent professional engineers who can sign off on the plans that you're not competent to prepare. And as much as we would like to think that we know all, we don't. So we need to be sensitive to that distinction. All right. Under professional obligations, 2B, again, now you'll notice the pattern here, Canon 2, and in rules of practice, it's the attachments to Rule 2, and under professional obligations, it's the attachments to Obligation 2. Now, I'm starting with B, and by the way, there were some ellipses under the rules of practice, because there are other items under rules of practice that are not directly related to the matter of competence. Likewise, we get down to professional obligations, and I'm sure you'll notice that we aren't starting with A, and we're not doing C. That's because I wanted to focus on the pieces of the code that are specifically addressing competence. So professional obligation 2B, engineers shall not complete, sign, or seal plans and or specifications that are not in conformity, with applicable engineering standards. Pretty basic. Don't sign a plan that doesn't conform to the standards. Now, this can be defined in a number of different ways. Standards may be contained in a code. And so if there is a code, in Pennsylvania, that might be the municipality's planning code or the International Building Code. Whatever code is in play, you have to comply with it. Now, I get the question fairly often, what if I know the code isn't good enough and I can do better? The code serves as a floor. Any service below the code is clearly defective. Now you can argue, and it has been argued, that there are pieces of the code that maybe are too rigorous and unnecessarily rigorous. In my municipality, they passed a fire sprinkler ordinance that was adding 5 to 7% to construction costs. I just think about it. That's huge. And they were demanding retrofits of existing homes. So there was some evaluation of that after a time, but while it was in effect, compliance was the minimum standard. If you know that the code is obsolete or your local jurisdiction is using an old version or new technology has come into play or circumstances have changed, you are free to design above the code. Now you may have to enter into negotiations with a client who knows the code in and out and knows that you're exceeding the minimum. But the fact of the matter is, as professional engineers, codes and like standards serve as a minimum, not as a maximum, and not as the only bandwidth in which you can work. 2D, engineers are encouraged to adhere to the principles of sustainable development in order to protect the environment for future generations. Now, this piece of the Code of Ethics is a relatively new one. I believe it was added 3 or 4 years ago, maybe a couple more than that, but anyway, very recent. And this requires that we step outside of our adherence to codes, for example, and pay attention to the implications of our work on a larger scale. So we are encouraged, it's not a requirement here, there's not a shall word or a must word. It's encouraged to adhere to principles of sustainable development. So what we see here is that as an ethical matter, we're being encouraged to pivot and not look exclusively at cost and not look exclusively at can we strip the land? Can we alter the profile? We're being encouraged to look at sustainable development. So that is a piece that we need to begin to fold into our work if we aren't already, because that is our forward-thinking ethical purpose. It doesn't do any good to meet your client's needs if the meeting of your client's needs today means you don't have a client tomorrow. So, all right. So, competence. There's a very famous case about obscenity, and the Supreme Court justice says, I can't define it, but I know it when I see it. And so competence is a little bit like that. It's hard to define, but if you are honest with yourself, you will realize that there are things that you're really good at and things you're not so good at and things you don't have a clue about. So those are exactly the 3 components. Know what you know what you do not know, and close the gap if you wish to become competent in the number 2 category. So work in number 1, know where your number 2 is, and if you want to work in number 2, close the gap so that you become competent. So there are some issues arising and developing in the area of competence, and they are in tension. One of them is that there is a trend toward specialization. Tighter and tighter, smaller and smaller boxes. A person can do work for 40 years designing bulkhead doors for a ship. And that becomes a very, very small area of competence. I have a beloved brother who works in the automotive industry, and his thing is doors. He has worked with doors almost his entire career at this particular manufacturer, and he is brilliant on doors. But that's a very small space. And so that's the kind of specialization that we're seeing more and more. The larger the firm, the smaller the box in which you may spend your career. In tension with that is that our clients are beginning to expect that we will have a vast array of cross-discipline expertise. Now, most of my clients can wrap their heads around the fact that I'm a civil structural, I can spell electrical. I just told you everything I know. Actually, when I went to my first fundamentals of electricity course in my engineering program, the professor introduced himself and said, okay, in this class, electrons go this way. We're going to call current going this way, unless you're in the military, in which case it goes that way. And I went, okay, we're done. I'm going to get through this class. I don't ever want to do this again. So that is not my expertise. And I can explain to my clients that that's a very specialized expertise, and I don't have it. However, they do sort of expect me to have some mechanical, electrical, plumbing when I'm doing residential work. Definitely plumbing, definitely mechanical. So they're expecting me to sort of ooze out of my civil structural realm. Now, of course, over the years, I've taken courses in thermodynamics. I've worked in HVAC design. So I have gained some competence in some of those areas. Electrical is still electrical and it's still over there. But this expectation in the marketplace for cross-discipline expertise is a challenge for us, especially looking to the future. One of the areas in which that demand for cross-discipline expertise is particularly challenging is as we work into artificial intelligence. As engineers, we are superb at developing hardware, machines to do things, equipment to do things. We're very good at that. Over here, we have a group of people who code software. And they are, hopefully, very good at what they do. But there is an interface between the hardware and the software. And the engineers may not be good at software. And the software developers may not have the ability to understand the instructions they're getting from the engineers. So we have a gap, potentially dangerous gap, in the interface between hardware and software. So I want you to know that NSPE is looking at ways to address that. We are currently working with NICET, which specializes in certifying for engineering technologies, at developing a certification so that people who work in QC, in design, in manufacturing, software development even, can work toward this central point, gain skills, gain competence, and we can provide them with a certification that says to an employer or a party building a team, this person is ready to bridge this gap between hardware and software and knows how to do it and how to do it well and how to do it competently. So the cross-discipline expertise is dragging our profession in a different direction from what we're accustomed to, and it's up to us to stay competent. And then, of course, there's the philosophical concept that if you are not moving forward, you are not standing still, you are in fact falling behind. And that is exactly the philosophy that led to the imposition of professional development hour requirements some years ago in most states. That is a way for the licensing boards to assure that we are not falling behind, that we are at least holding our own, if not moving forward. So this is an important component of assessing your competence. All right. We are going to take a look at some cases that have been issued by the Board of Ethical Review. Now, the Board of Ethical Review is a standing board of the National Society of Professional Engineers. They are people with professional experience in the ethical area, and they gather and cases are submitted to them, whether it's actual cases or ethical questions that have come up. We gather them from lots of different places, sit down and write up case studies so that there are tools out there for guidance when situations arise. Now, I mentioned earlier that if you call the ethics hotline, I'm the person that you will get. That is not your only tool if you have an ethical question. You also have an entire 60-year library of the cases that NSPE has issued. And we do try to go back and where things have changed over time, we try to annotate them so that we go, yeah, that's what we said back in '85, but that's not how it works anymore. So we try to keep that up to date so that you're not stuck in a Wayback Machine. But we are going to actually start with a relatively old case. The first two digits are the year, and then the digit after the dash, it just tells you which case that year it was. Now, the original case was about using a CD-ROM, which is a pretty obsolete technology. So you'll see in the brackets, I've added software, and that is just so we can use words that make sense to us today. All right, 89-3, competence, use of software for highway design. Here are our facts. Engineer A, a chemical engineer with no facilities design and construction experience, receives a solicitation in the mail with the following information. Engineers today cannot afford to pass up a single job that comes by, including construction projects that may be new or unfamiliar. Thanks to a revolutionary new software, specifying, designing, and costing out any construction project is as easy as pointing and clicking your mouse, no matter your design experience. Never designed a highway before? No problem. Just point to the highways window and click. Engineer A orders the software and begins to offer facilities, design, and construction services. So, was it ethical for Engineer A to offer facilities, design, and construction services? Question of the day. NSPE supports the concept that a qualified individual engineer should be licensed as a professional engineer. However, this does not mean that all engineers are free to practice without restriction in any and all areas within the whole practice of engineering. A chemical engineer has no substantive background or experience in the area of facilities design and construction. An individual seeking to obtain an acceptable level of competency in the basic elements of facilities design and construction should seek and be able to demonstrate appropriate engineering and related education and experience. And by the way, I'm going to stop here for a second. Sometimes I get questioned, why are you reading the slides? Well, here's the deal. When the BER does a case, we spend hours, even days, choosing each word with great care so that there is no confusion and things are clear. Consequently, since those words have been so carefully formulated, I want you to have them as they were written by the BER. So yes, I'm going to be reading a fair number of the slides, but that's important so that we see exactly the thought process that went into evaluating. And when we provide an answer, it's not just a knee-jerk, visceral kind of, oh yeah, it's got to be that. That we can walk you through the thought process and the analysis so that the tool is useful to you. So that's why you're getting it direct. Okay, the software that permits virtually anyone to specify, design, and cost out a project clearly is not an appropriate basis upon which an individual can obtain professional competency. Relying on a how-to software shows a general disregard for the high level of knowledge and expertise necessary to perform these critical responsibilities. Professional engineering cannot be reduced to an activity whereby practitioners rely upon computers and technical information instead of time-tested professional experience and engineering judgment. In other words, if you are taking on a project, you may not treat it like a menu at your favorite Chinese restaurant. Choose one from column A and two from column B and enter your order. That is not how engineering works. So here are the BER's conclusions. Technology has an important place in the practice of engineering, but it must never be a replacement or a substitute for engineering judgment. It was not ethical for Engineer A to offer facilities, design, and construction services under the facts presented. Now, I've presented this particular case a couple of times, and I sometimes get the question, well, I use finite element analysis software all the time, and I use modeling software all the time. And are you telling me I can't do that? I am not telling you you can't do that. But you need to come to those tools with the ability to know when the answer you get doesn't make any sense. So if you're doing a finite element analysis project and you are expecting a particular order of magnitude answer, let's say 20, you're expecting the answer to be between 18 and 27. And you get an answer of 31,000. A competent engineer knows instantly something's wrong. This is not right. There's something in here that is incorrect. The data is not right, whatever. There's something wrong. We need to go back and take a look. Our chemical engineer here would plug in whatever to his software or her software and would have no idea the 31,000 was not a reasonable answer. So yes, we can use tools to make it easier. But before you use finite element software, you learned how to do finite element analysis. And you can do a crude one, a quick one, even in your head perhaps, that gives you an order of magnitude so that you have a heads up if the answer is radically awry. Of course, one of the things that we learn in school is how to use safety factors. And we want to always build in a cushion in case we were off on a little something or off on our assumptions, or it turns out that the soil strength is not what the soil borings indicated that it was. So you have a safety factor. We build them into everything that we do. And that's why, because we don't know everything going in. So we want to design for the possibility of reasonably foreseeable alternative outcomes. So it's very important. We can use the tools, but we have to know how to do it ourselves, how to estimate the outcome so that we can recognize a problem quickly. All right, this is my takeaway from this particular case. Buying a paint by numbers kit will not produce a masterpiece. And that is exactly what this case was about. We have a person who bought a piece of software, paint by numbers, and believed or pretended to believe that somehow if he painted the numbers, put all the colors in the right space, he was going to get a masterpiece. So that is how we use tools in terms of competence. All right, next case. This is from 2002, case number 5, and it is competence using current structural design. Okay, here are our facts. This area of the country experiences severe weather conditions. Engineer A, who has experience with structural designs in this area of the country, designs the structural system on a building project based upon what Engineer A believes constitutes sound structural engineering principles. New and improved design methods to address the severe weather conditions in this area have recently been developed and published in the most recent technical literature. While Engineer A generally attempts to stay current on changing structural design trends, Engineer A was not familiar with this recent technical literature. Within a year of construction, severe weather conditions caused significant structural damage to the building. And Engineer A followed the severe weather design parameters that were recently published in the technical literature. The structural failure would not have occurred. Okay, so here's the question of the day for this case. Was it ethical for Engineer A to fail to follow the most recent design parameters for structural design in severe weather areas, published in the most recent technical literature? Okay, back to our canon. Engineers have a fundamental ethical obligation to practice in a professional and competent manner, and must make all efforts to perform professional services solely within their area of competence, and must not be unduly influenced either by employer or client pressures that could cause grave danger to the public health and safety. Now, We can all contemplate situations in which an employer puts us under pressure to do things a certain way. And we can all imagine situations in which the client puts pressure on us to do things in a certain way. In both cases, I think the most common one is cost. You can spend X dollars and no more, get it done for that many dollars. Well, maybe that many dollars won't get it done. And so we cannot be unduly influenced by pressures that would step in front of public health and safety. That is our number one obligation, before obligations to clients, before obligations to employers, before obligations to other engineers. Number one priority, public health and safety. The determination of whether an engineer is practicing in a competent manner is not something that is subject to simple evaluation, but can only be determined on the basis of all of the facts and circumstances involved in a particular situation. It is often based upon local standards, the time period in which the individual is practicing, client-imposed requirements, and various other considerations. Ethical impropriety involves more than the fact that an engineer designed a facility that fails. In order for an engineer to be found unethical for a design failure, the engineer must demonstrate some level of moral culpability. In other words, there must be some demonstration that the engineer was acting in an intentional, reckless, or malicious manner. For example, if the engineer was reckless or refused to take appropriate action, the board could conclude that the engineer acted in an unethical manner. However, the mere fact that an engineer did not follow the most recent literature and the professional practice resulted in some harm is insufficient, in the board's view, to find the engineer to be deemed unethical. The board believes that the definition of what is current must be reasonable, as engineers cannot be expected to incorporate each and every new and innovative technique or parameter that has not been fully tested or peer reviewed. That makes perfect sense. How many times has someone came forward? Oh, goodness gracious. How many times has someone come forward with the best new mousetrap, and 6 months later it vanishes because it doesn't work the way they thought it was going to work? It breaks too quickly. The mice scream for hours in the trap, et cetera, et cetera. The best, newest thing doesn't always survive the cut. And so when there's something put forward, that doesn't mean it's due for immediate implementation. In the law, what we get a lot of times in my legal journals are essays about what the law should be. But it would be a terrible mistake for me as an attorney to read that and go, oh, that's what the law is. No, this is a possible path in the future. And same with new developments, new designs, new approaches. They must be fully tested before we let the public stand on them, if you will, because our primary concern is the public health. Following a reasonable period of time, innovative techniques and parameters may be incorporated into generally accepted practice, and at such time, once well-defined and as part of the body of technical knowledge, such techniques become standards that should be followed. The board would note that the facts and circumstances in this case do not indicate that severe weather design parameters and methods constituted standards. Had those parameters and method constituted standards, this board might have reached another result. So remember, this was a new technique or a new approach that was published in the most recent technical literature. Under the facts presented, the board is of the view that Engineer A's actions were within the basic standards of the profession of engineering, and the board cannot conclude that Engineer A acted unethically. So I shared this case with you because it serves to remind us that there is a line between expected competence for practice and the integration of new techniques. And there is a range between these two where the new technique moves for greater use, greater acceptance, incorporation into codes, etc. And it will eventually either become a part of the standard or it will fall away because it doesn't meet our expectations. The conclusion: it was not unethical for engineer A to fail to follow the most recent design parameters for structural design in severe weather areas, published in the most recent technical literature. Okay, so if there's a gap between the latest new mousetrap and appropriate engineering behavior, how do we know where in there we are? Okay, so even understanding the BER's conclusion, the cutting edge does not equal a new standard of care. What are our obligations to stay current? So we're going to go back to professional obligations and look at 2A. Engineers' work must be in conformity with applicable engineering standards. In the previous case just said, new and different may gradually become part of applicable engineering standards. Engineers, 2D. Engineers are encouraged to adhere to the principles of sustainable development, meeting human needs while conserving and protecting environmental quality. So what we're seeing with 2D, and we talked a little bit about it at the beginning, is that sustainable development in the past 20 years has gradually moved up the ladder to the point that it's almost part of the definition of protecting public health and safety. Not quite, it's an encouragement, not a requirement. But we can see that sustainable development is moving up the path, and that we can anticipate, from sitting where we are today, that sometime in the immediate future, probably during the rest of the time that we're practicing, sustainable development may actually move into a component of public health and safety. Because public health and safety is not just today. Public health and safety is forward-looking as well. Engineers, this is 2E, engineers should keep current in their specialty fields by engaging in professional practice, participating in continuing education, reading the technical literature, and attending professional meetings and seminars. Now, before I go on to the next section, I want to talk a little bit about how you do that. Now, I gave you a list of options here. Actually, the code gave you a list of options here. But I want to point out that you have other opportunities. It's not just going to events at which someone puts information into your head. It can also be volunteering under the supervision of an engineer who is expert in the area that you're working on. It can be going to pilot programs, touring sites, seeing how it works. When a radical new material comes along, the norm would be to put it in a test environment, expose it to different circumstances, and see how it performs. So put yourself out there, offer to be a test site for a new material. Sometimes your clients are interested in incorporating test facilities as part of a project, especially if some of it's funded by another source. So they may want to try a different kind of piling or a different way of installing a piling, knowing that people are going to be coming back and forth in the next 10, 15, 20 years, checking out the condition of the piling. But that may be fine with them, as long as you, of course, make the guarantee that if it should not perform to expectations, that you will take care of getting it replaced. So work with your colleagues, talk to your colleagues. Don't just talk to colleagues who do exactly what you do. Talk to colleagues who work outside your field, because you may discover that what you learned when you got your superb engineering degree X years ago that the environmental requirements that your structure or your project or your machine is going to have to deal with are different from those that you learned earlier. So it isn't enough to just be aware of what's going on in your own discipline. You also need to know what's going on in the world in which your discipline is. Okay. Here is an example of a technology that has moved up. If it isn't already a standard, it's pretty darn close. This is building information modeling. This is, I would say, a post-CAD. This is the next evolution post-CAD, computer-aided drafting. This is an example of a situation where we're pretty far over in that gap. I have seen projects where it was assumed that building information modeling was going to be a piece of the project, which meets my definition of an applicable standard. I've seen situations in which it was offered as a supplement to the RFP to enhance the overall performance of the project. So building information modeling is an example of a technology, a change that is pretty far along the path and may in fact already have achieved status as an applicable standard in some disciplines. Okay, here's a relatively new product, lightweight foamed glass aggregate. It is made from 100% recycled glass, and we're going to take a little bit closer look at it. Lightweight foamed glass aggregate is made from 100% recycled container glass. It recycles approximately 140 million glass bottles per year. Now, I will tell you that if you go exploring for lightweight foamed glass aggregate, it is available in limited parts of the country. Now, I asked, so I'm assuming you're asking in your heads, why isn't it everywhere? There are glass bottles produced everywhere. Well, obviously, they're going to produce plants to produce they're going to build plants to produce the foamed glass aggregate in places where they have a ready access to a supply of recycled glass. And unfortunately, there are significant parts of the country that do not recycle glass. It goes directly into a landfill. And in those parts of the country, it is not cost effective for them to build a plant because they would have to pay for the material rather than just getting it through the recycling process. So it does not have National Geographic availability. That is not because of any reason except lack of raw materials. Okay, lightweight foamed glass aggregate is an extremely low density product. It is approximately 85% less in weight than most quarried aggregates. That's like, you know, my kid can carry it. Well, no, my grandkid can carry a bag, which is most assuredly not true for aggregate. Lightweight foamed glass aggregate has been used for over 20 years on infrastructure projects. Began in Scandinavia as a way, and this central image focuses on that. There is obviously a significant issue in the northern climes of frost heaving with the roads. So they were the first to implement foamed glass aggregate as substrate for highways because it has flexibility. It can absorb a fair amount of water without expanding and contracting. So it's very stable, very lightweight, gives flexibility. It's also being used in infrastructure projects as backfill for embankments, retaining walls, significantly reduces the torque load on the retaining walls because it's so much lighter. And it has substantially different hydraulic properties. So it's a really cool material. It is green. And if you don't know about it and you're in a situation where you're designing road beds or you're designing retaining walls or you're doing landslide repairs, those kinds of things, you need to know about this. Now, each of these products when it first emerges on the market, generally has only one purveyor, maybe two, or the two have slightly different products, slightly different manufacturing techniques, whatever. So I've tried to eliminate product ads from these discussions, but in a couple of cases I haven't been able to do that because if I took away the name of the product, you wouldn't have any idea what I was talking about. Okay, here's a third new technology. We've had 3D printers for what, 25 years now? But this is 3D printing on a spectacular scale. It is a technology that is currently in use in Africa, in Asia, and in the southwestern United States. This is a technique where the depositing material, this is additive manufacturing, the depositing material is actually local clay or local dirt. It's turned into a slurry and it's printed by the 3D printer. This was an early effort, if you will. I picked it because it's gorgeous. I think it's gorgeous. As we get more experience with 3D printing on this scale, they are now able to do much more traditional square, rectangular, things we would recognize right off as a traditional house. But what is so attractive to this, to me for this, is it's using indigenous materials. So we have very little transportation costs for materials. As you can see, the 3D printer itself is not some huge, enormous thing. It is not your household 3D printer scaled up. So actually getting the 3D printer on site is not a huge deal. I mean, it's not a nothing deal, but it's not an overwhelming construction project in its own right. The insulating properties of the indigenous materials are impressive, and the walls are very thick, going back to some, 15th, 16th century insulating properties of materials. So very thick walls, interesting shapes, excellent insulation, and they can be creative and beautiful. They are, because of the reduction in cost, the pilots, of course, were not inexpensive because pilots never are. But they are, Habitat for Humanity is now using this technology to build houses both in Africa and in the US and the Southwest. Because of the nature of the finished product, they are able to be much more traditional in construct. So we're not seeing a native village, for example, that suddenly has a cinder block and tin roof houses. Their houses can be made very much in consonance with their local environment. I think this is really exciting. And by the way, I guess you can't even see my necklace. My necklace is made of poured concrete. And that technology is the beginning of the 3D printing for more, I can't say more traditionals, because truly traditional is indigenous soils. Modern traditional materials has that. So we're now using extruded slurry, where perhaps the soil isn't stable and we can't use that soil. But we're moving that one right along. Okay, back to Scandinavia again, with the largest standing timber supply in the world. They are looking at timber high-rises, and the world's tallest timber structure is in Sweden, I think. But we're not talking about 5 or 6 stories here. We are talking about very high-rise. And they are doing some really fantastic things with laminate. We've used glue lam beams for a long time, 40 years. But these are some new techniques where the adhesive is actually also fire retardant. So these structures are now more doable than they've ever been before. So You need to know what's going on. I mean, even just a material like wood, how it is being used today is different from how it was used 20 years ago. All right. Solar panels are not new, but there are some interesting applications going on. I have to give the copyright credit here, so you're getting some information there. But this concept is to put solar covers over irrigation canals, which has two huge benefits. One of them is gathering energy without using up arable land to do it, which is one of the big issues with solar farms, is that if you're solar farming, you may not be other farming. So this enables us to gather energy without taking up arable land, and it substantially reduces water losses from evaporation. So it has water conservation benefits as well. And since you already have the canal and you were already concerned about moving water from one place to another, conservation from evaporation is like a huge big deal. All right. Now, we're going to talk for a minute about a relatively new product called fiberglass rebar. Excuse me just a minute. Why are we going to talk about fiberglass rebar? Well, we do not know what caused the collapse of the Champlain Towers at this point in time. We do know that it was already undergoing a 40-year inspection. And the reason for the 40-year inspection is that in an exposed saltwater marine environment, erosion is an issue. That was known. That was why the code required 40-year inspections. So corrosion of rebar in a saltwater marine water environment is a very real problem. And as the rebar oxidizes, it reduces in its strength carrying capacity, and it also begins to invade the concrete, causing spalling. And so we have a cascading reaction of failure. So what about fiberglass rebar? It is actually stronger than steel rebar. It requires less cover of concrete over the rebar. It is lightweight, easy to cut, easy to handle, corrosion resistant, has low thermal conductivity, and it is electromagnetically neutral. So I always harp on looking for unintended consequences. Usually that means what is the unintended bad consequence. But in this particular case, we can look at some unintended good consequences, like lower cover concrete. The primary focus here, of course, was going to be corrosion resistance. But these other benefits come along with it. And so it's got additional capabilities. And I want to point out that steel is not a renewable resource. Recyclable, yes. Renewable, no. So as we look away from materials that will eventually exhaust, fiberglass rebar is one that comes up as an option. Okay, I wanted to share with you some of the data. If you look at the tensile strength, the fiberglass rebar has 2 to 3 times the tensile strength. The bomb strength doesn't play as much in the applications I work in. The thermal conductivity, however, can be huge, especially in an industrial setting. The electrical resistivity is can be very powerful if you're in a situation where, and particularly in a marine environment, where you could actually set up a battery by accident. And so the electrical resistivity is very useful. Now, look at the unit weight. This is pounds per cubic foot. Stainless steel and steel are, same weight, 490-ish pounds per cubic foot. Our fiberglass rod is 110 to 130. So think about when you're factoring in your dead loads, how much of a reduction in bed load that is. And then we get to the required concrete cover. And for steel and stainless steel, you're looking at 1.5 to 3 inches of cover. And the required cover for the fiberglass rebar is 3/4 of an inch. So if a significant portion of your concrete is required for achieving cover, you've got a lot of savings in concrete. Now, I will, again, we do not yet know what the issue was or issues were in the Champlain Towers collapse. However, I have looked at some photographs. There are some things I believe to be true, but I have seen some photographs which are irrefutable of a situation in which in one of the columns where there should have been 3 or 4 rebars, there were like 20 or 30 or even 40. It was absurd. And there was absolutely not a 1.5 to 3 inches of concrete covered. There was very little concrete in that column. It was a bunch of rebar with a concrete skim coat. Now, that is what I observed from the photograph. I'm not going to draw any conclusions about whether that factored into the failure. I merely want to point out that concrete cover is a significant issue. And if you do not have sufficient concrete cover and you're using a steel rebar, you are vulnerable to failure by corrosion. So it is very much worth paying attention. And if you work in this field where you are specifying rebar, you should know about this product, know about how it performs, and decide whether or not you want to begin incorporating it in your work. There was a high exposure 10-year pilot. The pilot is going on past 10 years, but at 10 years they did core samples, and there was no indication that this wasn't a brand new project. There was no corrosion, no breaking, no spalling. It was pretty amazing, actually. So I would invite you to, if you don't already have this in your repertoire, you need to learn about it, especially if you're practicing in marine environments. Specifically, these are the 6 favorite applications for fiberglass rebar. Obviously, a bridge, whether it's saltwater or freshwater, still in a water environment, marine installations in general, offshore platforms and so on. Again, corrosion. Tunnels and mining operations where you may have water intrusions, water treatment plants. Frankly, I think this is where we're going to see it, the most immediate application, because anything we can do to reduce the size and weight of a water treatment plant makes it more accessible. And then there are industrial applications, whether you're dealing with a water environment or a lot of chemical environments. So these are some of the applications for which fiberglass rebar may be a good choice. So you need to be aware of them and learn about them if you're in this area so that you're equipped to use technology. Now, I would say that the foam glass aggregate and the fiberglass rebar in our little bandwidth of new and innovative, moving towards standard, I would say that both of those products are well past half. The foam glass aggregate, I believe, has 14 state departments of transportation that have accepted it as a material. So it's well past the halfway mark. Fiberglass rebar is not as far as the foam glass aggregate. It's, let's say, it's a third of the way through our little bandwidth here. But they are things you need to be aware of so that you can be competent. Okay, we're now going to look at BER case 02-7. Change of plans, revisions to a subconsultant's work. Here are our facts. Engineer A is the prime design professional on a facilities project that includes the surrounding landscaping design. Engineer A retains subconsultant LA, landscape architect, in case you were wondering, to prepare a planting scheme. Subconsultant LA's scheme includes 5,000 plantings based upon projected plant mortality projections with a 50% survival rate, which is the generally accepted and established industry and professional standard. So that 50% survival rate is a standard. After receiving subconsultant LA's proposal, Engineer A reduces the number of required plantings to 3,500 in order to reduce expenses for the owner. Engineer A also includes the 3,500 number in the bidding documents with an added requirement of a 2-year planting warranty, specifying 200% replacement in the event the survival rate is 60% or less. Now that if we looked at that first standard, it was a 50% survival rate. So if I plant 5,000 plants, I'm telling you, I expect 2,500 of them to make it. That says nothing about a warranty and nothing about a replacement standard. In fact, it assumes there won't be replacement, that the 2,500 will do the trick. So our Engineer A has not only reduced the number of plants, they've specified a 2-year planting warranty. And if a warranty is provided, it's usually 1 year. A 2-year planting warranty, 200% replacement, and raised the survival rate from 50 to 60%. Contractor is selected as the low bidder, and contractor plants 3,500 plants. A year later, owner notifies contractor that the survival rate was 60%. The contractor is required to plant 1,400 additional plants. Owner suffers significant inconvenience, additional maintenance costs, and long-term expenses. And the contractor suffers significant additional expense. Was it ethical for Engineer A to reduce the number of plantings recommended by subconsultant LA to 3,500 and increase the survival percentage in the specifications in order to save expense for the owner? Question 2, was it ethical for Engineer A to include a requirement of a 2-year planting warranty specifying 200% replacement in the event survival rate is 60% or less? So here are the code sections we're looking at. Section 1.2, engineers in the fulfillment of their professional duties shall perform services only in areas of their competence. Gee, where have we heard that before? Section 2.2a, engineers shall undertake assignments only when qualified by education or experience in the specific technical fields involved. Section 2.2b, engineers shall not affix their signatures to any plans or documents dealing with subject matter in which they lack competence, nor to any plan or document not prepared under their direction and control. Section 2.3a, engineers shall be objective and truthful in professional reports, statements, or testimony. They shall include all relevant and pertinent information in such reports, statements, or testimony, which should bear the date indicating when it was current. Section 2.3b, engineers may express publicly technical opinions that are founded upon knowledge of the facts and competence in the subject matter. And Section 2.5, engineers shall avoid deceptive acts. So, discussion. This case is about 2 separate issues: changing the number of plantings and changing the construction contract provisions. And it addresses the quandary of the engineer who is the prime design professional responsible to the owner for the overall project in modifying the recommended design of the subconsultant. Changing the number of plantings? If a civil engineer changed the scope of design of an electrical engineer, would that be ethical? In almost all cases, no. Is changing the landscape architect's proposed number of plants in consultation with the owner unethical? That's our question. Changing the construction contract provisions is a separate issue. This impacts the owner's risk and cost and are made at the owner's choice. Did engineer A discuss these changes with the landscape architect? Our facts don't say, but engineer A should have. So, question of the day. Was it ethical for engineer A to reduce the number of plantings recommended by the subconsultant to 3,500 and increase the survival percentage in the specification in order to save expenses for the owner? So 3 options. And unfortunately, we don't have an opportunity for participation right now. So do it in your head. A, it was ethical. B, it was not ethical. Or C, I'm not really sure. Here's what the board said. It was unethical for engineer A to reduce the number of plantings to save money for the owner without consulting the professional subconsultant landscape architect for a new 3,500 plant plan. It would have been ethical to include a requirement of a 2-year planting warranty specifying a 200% replacement in the event survival rate is 60% or less, if engineer A had consulted with subconsultant A as suggested above, because the survival rate and the replacement policy would have been properly addressed. Now, I particularly wanted to bring this case to your attention because it has a dissent. I think that's helpful. I think it's important that you know that all ethical questions do not have concrete, black and white, this is it, go away answers. Sometimes 2 highly ethical professional engineers could disagree about what the correct answer is. So here's the dissenting opinion. If engineer A felt he was competent to do so, it was ethical for engineer A to specify the number of plantings in the project, even if this was less than the number recommended by the subconsultant hired for advice. And it was ethical to structure the planting element of the construction contract to identify a higher survival percentage. So what we had here was a situation in which the dissent said engineer A is already required to evaluate engineer A's own competence. So if engineer A has self-evaluated and determined that engineer A is competent to make changes to the landscape plan, then engineer A should be free to do that without consulting with the landscape architect. And it was ethical to structure the planting element, all of the contracting provisions, the survival rate, the replacement rate. Well, those are the 2 biggies. That it was ethical for the engineer to make those changes because those are contractual changes and the contractor didn't have to sign up for them, didn't have to bid the job if they didn't want to. So they signed up for 3,500 plan, 60% survival rate, and 200% replacement. That's on them. They took that risk. Now, I would split this apart, and I would say I agree with the dissent that it was ethical to change the contract provisions because those have no technical engineering implication, direct engineering implication. I agree with part 2 of the dissent. I would not feel the need to consult with the landscape architect about changing survival rate or the replacement warranty. Those are contractual provisions. Now, if I were changing the survival rate to 90%, I might feel the need to check with the landscape architect because that's a pretty radical deviation from the industry standard of 50%. 60% is more, 20% more, but it's not crazy more. So I agreed to dissent on number 2. Number 1, I understand the dissent. If the engineer felt competent, the engineer could make the changes. And the majority view was that the engineer should have consulted with the landscape architect before making the reduction. I'm inclined to agree with the majority here. Here's why. Plantings serve a lot of different purposes, especially if we go back to our encourage to follow sustainable practices. The difference between 5,000 plants and 3,500 plants may be the difference between stabilizing a bank, the different and not, between having enough vegetation to slow down water runoff or not. We're not just talking about cosmetic issues. Now, yes, one would hope that engineer A would have brought all of those things to bear. But landscape architects do have specialized training in how to use vegetation for positive purposes. It's not just cosmetic or for fragrance or anything like that. Landscape planning has a great deal to do with stormwater runoff, erosion prevention, slope stability, all those kinds of things. So I do tend to agree with the majority in this particular case that the right thing to do was for engineer A to consult with subconsultant landscape architect. Perhaps if we can only plant 3,500 plants instead of 5,000, we're going to choose a different plant, one that spreads more quickly, for example, a creeper instead of a yew, something like that, because we have to achieve our erosion, runoff, and bank stability concerns. So that's where I came down on this one, for what that's worth. I just wanted to share with you both the fact that there was a dissent and the fact that reasonable people can disagree about the correct answer. The important part of the exercise, though, is that you intentionally and thoughtfully walk through it. No knee-jerk reactions. Walk through it. Consider the issues before you in determining what's ethical behavior for you. Okay, I wasn't sure we'd have time for this case, so I don't have much of it in the PowerPoint so that you wouldn't feel like you were missing out on something really important if you had to skip it. But I'm going to be able to talk about it. We're going to look at 18-5, boiler valves and switches. Now, I got to tell you, if you pull 18.5, competence doesn't show up as a primary focus for this particular case. So I'm not going to do the whole case because there are two layers to it, one of which has nothing to do with competence, but the other one does. So we're going to take a look at the first part of this particular case and take a look at how competence plays in. So engineer worked as QC engineer, quality control, for Boyle-Co. Boyle-Co began using a more economical supplier of valves and switches. But engineers' product testing demonstrated that new suppliers' components were inferior and potentially unsafe. And we are talking about valves and switches for boilers. Okay. Engineer rejected the first shipment. Engineer's supervisor was also a PE, and PE supervisor overruled engineer's rejection and declared the parts acceptable. Engineer went to management with safety concern. Supervisor fired engineer for insubordination. Engineer contacted the federal agency with the safety concerns. Now, supervisor fired for insubordination is part 2 of this particular case. We are not going to work through that today. That's not the point. What we are going to focus on is rejection, overruled, went to management, contacted a federal agency. Now, one piece that comes into play here is the engineer contacted the federal agency after being terminated. So as we think through this case, ask yourself, If engineer hadn't been terminated, talk about the issues here. Did engineer have an obligation to go to the federal agency, even if still an employee? Okay. So the Board of Ethical Review has, on a number of occasions, examined cases relating to the obligation of engineers to report activities that endanger public health and safety. If one of them is 89-7, which was a structural integrity case, and it was unethical for engineer A not to report safety violations to the appropriate public authorities. And that was a tension in that particular case between client confidentiality and the paramount duty to public health and safety. And remember, from the very beginning, I said these are not equal. Public health and safety trumps every time. In 97-3, there was a public agency that retained the services of an architect and an engineer, and architects and engineering firm, and the architect engineering firm hired a subconsultant to perform bridge inspection services. Engineer A's scope of work was solely to identify pavement damage on the bridge and report it. 3 months prior to the beginning of the overhaul, police officer B lost control of his patrol car, crashed into the bridge wall. The wall failed to restrain the vehicle, which fell to the river below, killing police officer B. While conducting the bridge inspection, although not part of the scope of services for which he was retained, engineer A noticed an apparent pre-existing defective condition in the wall close to where the accident involving officer B occurred. Engineer A surmised that the defective condition may have been a contributing factor in the wall failure and noticed this in his engineering notes. Engineer A verbally reported the information to his client, and the client then verbally reported the information to the public agency. The public agency contacted the prime, who then contacted the engineer and asked him not to include this additional information in his final report since it was not part of his scope of work. Engineer A said that engineer A would retain the information in his notes, not include it in the final report as requested. Engineer A did not report the information to any other public agency or authority. The BER noted that engineer A, in ruling that it was ethical to retain the information but not included in the final report, the BER noted that engineer A acted reasonably under the circumstances by properly balancing the obligation of the engineer to be faithful and not disclose, and the obligation to hold paramount public health and safety. This is because there was nothing under the facts to indicate anything more than engineer A's best guess. There was nothing noted in the facts to indicate that engineer A was a structural engineer. The BER noted that to place this information in a final report would not be responsible and could unnecessarily inflame the situation. Therefore, the BER concluded that engineer A took appropriate action, first in coming forward to his client with the information, and then by documenting the information for possible future reference as appropriate. It would have been improper for engineer A to include reference to the information in his final report, particularly since it would have been based on speculation and not careful testing or evaluation by a competent individual or firm. Okay, run that by you again. It was not improper. No, excuse me, it would have been improper for engineer A to include it in his final report because it was his best guess, and this was not his area of competence. However, or at the same time, the BER determined that engineer A had an obligation to follow through to see that the correct follow-up action was taken by the ultimate client. Only if the public agency did not take corrective action after engineer A followed up should engineer A consider alternatives? For engineer A to have reported this information to a public authority under the circumstances as outlined in the facts before determining whether corrective action was taken would have been an overreaction and could easily have risked jeopardizing the professional reputations of its client and the public agency. So let's go to our boiler. It is the BER's view that the engineer A's actions were consistent with the NSPE Code of Ethics. Engineer A's action in first alerting his immediate supervisor and then contacting higher management when the immediate supervisor overruled demonstrates he made a good faith effort to exhaust internal mechanisms within the company in order to address what he reasonably viewed as a serious public safety concern. Now remember, QC engineer did product testing before making the ruling. So that's how it's different from our Officer B situation. Engineer A's actions in contacting the federal agency and detailing the threat to public safety were justified, and were consistent with the Code of Ethics. So, engineer A's actions in contacting the federal agency and detailing the threat to public safety posed by the former employer were justified and were consistent with the Code of Ethics. So I wanted to bring this case to you because I wanted to show you, I thought this was a really good case. We're taking a look at where competence comes into play in our duty to report. In the police officer B case, engineer made an observation and thought, well, yeah, there's that defect over there. I wonder if that played a role. Well, Joe Schmo could walk by and say, gee, there's a crack in the wall. I wonder if that's why Officer B's car went over. No special skill, no analysis, no testing, no evaluation, didn't review the drawings, didn't review intermediate inspection reports. So it was not made from a place of competence. Whereas in our boiler, valve, and switch case, QC engineer was in a place of competence to begin with, had done product testing, and brought those concerns forth. So we have a different outcome based on the competence of the observer. Now, I will raise up to you in this particular case, if you're in an airport after 9/11, see something, say something. You see it everywhere. Signs, public service announcements, it's everywhere. That really is a very good encapsulation of our responsibilities as professional engineers. If we see something, we need to say something. On another day, we'll take a look at the I-35 West Bridge collapse in Minneapolis, and that will come into play in that particular case. All right. Somehow I lost my ability to change my slides. Hang on just a second here. There we go. Okay, the final situation we're going to look at is the Cypress Street Viaduct. This is a historical case. The plans for the Cypress Viaduct were drawn up in 1949 as part of the Nimitz Freeway, or I-880. The viaduct was a two-tier highway with 5 lanes per deck. Since bedrock was more than 150 meters below the surface, much of the bridge was constructed on soft mud. I can anticipate a problem. During the period of construction, 1956 to 57, the California state seismic criteria required planning for a lateral force of 0.06 times the dead load. Cypress Street Viaduct collapsed October 17, 1989. On that day, the magnitude 7.1 Loma Prieta earthquake shook most of Northern California, causing tremors from Santa Cruz to Sacramento, caused more than $6 billion in damage, and resulted in 3,900 injuries and 63 deaths. The Loma Prieta earthquake also caused a 1.4 kilometer segment of the upper deck of the Cypress structure to slam onto the lower deck, and 42 of the 63 deaths were on the Cypress structure. California traditionally built in preparation for earthquakes. So why wasn't the Cypress Viaduct able to withstand the quake? Two major factors led to the collapse of the Cypress structure. The first was the geotechnical features of the San Francisco Bay Area. During the earthquake, the Cypress structure vibrated tremendously. While more suitable soils served to dampen vibration, the soft mud in the Bay Area where the structure was constructed actually increased the vibrations fivefold relative to the rest of the freeway, which was built on rock. So we have this much of the freeway built on rock, and the Cypress Street Viaduct, which is vibrating at 5 times the amplitude of the earthquake. Post-disaster analysis revealed that the angular frequency of the seismic waves of the Loma Prieta earthquake matched almost exactly the angular frequency of the individual horizontal sections. And these sediment reverberations were not predicted in the original design. The second major factor was the design of Cypress Street Viaduct and its response to earthquakes. While engineering technology had progressed since 1957, the Cypress Street Viaduct had not been retrofitted to reflect advancements and was not adequate to withstand a large-scale earthquake. The disaster might have been avoided had the city of Oakland followed repeated recommendations that the Cypress Street Viaduct be upgraded with newer engineering developments. And this photograph just stops me in my tracks every time. Anytime you see a structure pancaked like this, you know it's gone incredibly wrong. The Cypress Street Viaduct was constructed of reinforced concrete. Sorry, voice getting tired. The upper and lower levels were connected by 2 column vents in a combination of cast concrete and 4 pin connections. Unfortunately, the upper deck was not securely fastened to the lower deck in some sections, making the concrete susceptible to vibration. So right off the bat, we've got construction issues. When the earthquake hit, the pins connecting the upper level and the lower level also began to vibrate, causing the concrete around the pins to crumble and break. Without concrete under the support columns, the column slid sideways under the weight of the upper deck and allowed a large portion of the upper deck to collapse. You've seen wedding cake videos where the tiers sort of slide and it's always in slow motion. That's essentially what happened here. The vibrations took off the concrete cover and the columns just slid sideways. Today, the viaduct is gone. It is now Mandela Memorial Parkway. This tragedy served as both guide and inspiration as engineers undertook new types of design to upgrade and create safer structures that could more effectively withstand powerful geological events. Now, I want to go back a couple of slides. This is the viaduct. Now, what you can't see from here is that this was part of the 50s and 60s construction of the interstate highway system. It was built on the boundary between an industrial area and a minority residential area. Significant number of minority homes were destroyed for its construction, and minority-owned businesses and minority-owned houses of worship. And it separated that neighborhood from the rest of Oakland. What you see today is that that separation has been eliminated. It is a pedestrian walkway the entire length. No, that's not quite true. There are pedestrian lanes throughout. Part of it is pedestrian only, but there are some areas where cars can travel. there is pedestrian parking. But this is now a restorative is perhaps the right word. It is now a memorial parkway, obviously, to the people who were killed, but it's also a place of restoration to the community that was harmed when the Cypress Street Viaduct was built. Okay, so we've talked today about knowing what you know, knowing what you don't know, and closing the gap if you want to move into a new area of competence. So how do we gain competence? There are aspects of engineering ethics that are not wholly within your control, but competence is not one of them. If you want to get into new areas, take undergraduate or graduate courses, attend seminars, read journals, observe, shadow, find a mentor. Now, I mentioned when we started that I started back to school this fall. In my position with NSPE, I need to have a really strong grasp of how to implement those sustainable development goals that we're encouraged to meet. I don't have that experience, so I went back to school and I'm taking graduate courses. So that's how I've determined to gain competence. I did not believe that it was enough for me to be a senior director of professional competence or professional practice and not be able to give my members specific examples of how sustainable development comes into place. I am gaining that competence. If there's a specialty exam, pass it. If there's a certification, do what it takes to qualify. No matter how long you have been licensed, think of yourself as an engineer intern or an engineer in training relative to this new area in which you're attempting to grow your competence. So set aside, I'm a PE and I've been a PE for umpteen hundreds of years, and think of yourself as an intern. Open your mind to the fact that you actually can learn things from other people. And that is how you can expand your competence into new areas. But never learn new competencies on the backs of clients or the public. So what does that mean? Don't do experiments without full disclosure, full consent. Those are the two biggies, full disclosure and full consent. Your client may be willing to let you do a pilot as part of the facility. I mentioned that earlier, but don't do it without permission and consent. And that was what I had for you today. I wanted us to walk through aspects of competence, how to self-evaluate and determine that you have it or you don't. I wanted to walk us through how to recognize when you are asked to do something for which you are not competent. And in downtimes, that can be very seductive. If times are tough and you are hungry for work, it may be tempting to expand your practice into areas that you're not prepared to do competently. That's a terrible risk. It is an immediate violation of your duty to keep public health and safety paramount. You can't very well do that if you don't know what you're doing. And then we talked a fair amount about closing the gap. If you want to work in a new area, or if your discipline has moved beyond you and you need to run quickly to catch up, those two aspects are in play in terms of closing the competency gap. I told you I was a materials aficionado. So I wanted to share with you the excitement of learning about new materials that can really, really change things. New ways, new techniques, new approaches, new ways of doing analysis. Times are really exciting right now. And as we interface with artificial intelligence and machine learning, we're going to find ourselves able to do more and more astonishing things. But going back to my finite element analysis example, you don't know about what the right answer should be. You don't know if machine learning produced a wrong answer. So it doesn't change the obligation of the engineer to know what the outcome ought to be, approximately. Maybe not to 4 decimal points, but you should have a general idea of the order of magnitude for what you're looking for. And if it comes back saying you should use one size of steel that's 1/10 the size of what you normally use, there's a good chance something's wrong. So it is a part of your fundamental duty to keep the public health and safety paramount that you be competent. And it is part of your encouraged transportation of yourself towards sustainable development. You can't do that if you aren't competent in the area of sustainable development in terms of knowing how that works, what does it mean, what are the implications, how do we budget for it, all of those kinds of issues. You have to be competent in that area in order to fulfill what will, in not too many years, move from encouraged goal to minimum standard. Be aware, be on your toes, stretch yourself, learn continually. And remember, if you're not moving forward, you're moving backwards. Thank you very much.